All right, yeah. We have a couple of templates available, and I opened the routing template here to demonstrate you how you can customize a specific model in order to incorporate business rules or other things you want the model to consider there. And for that, I will use one of our previous blog posts from a couple of weeks ago, where we had a small retailer with a couple of shops. And I already downloaded the input demo for that, or the input file. And you can see we have two vehicles here. We have a couple of shops placed in Cologne. So that's the use case or the scenario we are using here for this demonstration. So let's go back to our model. What could the first step be to customize this? The first step could, for example, be to remove some of these inputs and options that are coming with the template. So let's just get rid of a couple of those and also the options that are relevant for those inputs, just to make the model a little bit smaller and more relevant for our scenario. And the first thing we could do right now is to check whether the model can solve our input that we use here. So let's start the solver. It takes a moment, and we can have a look at our solution. And you can see here, the solution shows you the routes that are generated for our vehicles. So we have vehicle 2 here with 2 shops assigned, Chorweiler and Pulheim. And vehicle 1 has a couple of more shops assigned. No shop is unassigned. So the setup here was such that every shop was possible to assign to one of these vehicles. So this is like the first step in order to customize the model. But what if there are like specific business rules you want to incorporate here? So let's say we have a rule where we want to avoid certain combinations of shops in a route. And for that, in order to add it to the model, we can create a custom constraint. Here, the first step would be to have this data that you want to use in your custom constraint also available. And as I said, we want to avoid certain combinations of shops. And in order to achieve that, we have a classification of these shops. So some shops are classified as large shops, other shops are small or normal here. So that's the classification. And we need this in our input in order to use it later in our model. And you can see we already have this here, which means that we can directly go back to our model and use that information. For that, of course, we first have to read in this information. So we create a new field here in our input struct, which will then contain the classification map from the input file. And the next step we need to take to add a custom constraint to the model is we need to create a new struct that defines our custom constraint. I call it here the size classification constraint. Right now it has 2 fields, or it will have 2 fields, stops and the classification map. And the next step is crucial for our custom constraint. So we need to implement the violated function here, which implements the actual business rule we want to incorporate in our model. As I said, we want to avoid certain combinations. So we want to avoid more than one large shop in a route. You can see here, it's quite simple to implement this. We just iterate over the route. We have a counter in order to count the shops that are classified as large in the route. And whenever we have more than one large shop here in our route, we return true in order to say that this route violates our function or our custom constraint. And if we don't have this situation, we return false in order to say that this route is not violating our constraint and can be used. So that's all we have to do to set the business rule or implement the business rule. But then, of course, we also need to add this constraint to our model. So let's do that. First of all, we need to initialize our constraint struct here. So we set the fields of this struct according to our input. And then, of course, we also need to add this constraint to our model. And for that, we can use the constraint option, which adds this constraint as defined here and above to the model. And we can explicitly say for which vehicles this constraint should be considered. In this case, we want it to be considered for every vehicle, but it might also be possible that you have certain constraints or rules that are specific for individual vehicles. So you could add more constraints here and define your model in that way. So that's all we have to do to add the constraints to the model. So let's solve this. Again, I will create a new output here so that we can compare the new solution with the previous solution. And let's see if the constraint worked. So let's have a look at the JSON file and the solution. Maybe you remember Ehrenfeld and Altstadt were both the shops that were classified as large, and we wanted to avoid both shops on the same route. So here you can see vehicle 2 has assigned Ehrenfeld and Pulheim, so only one large shop, and Altstadt is assigned to vehicle 1. You can also see all shops still can be assigned to our vehicles, so no shop is unassigned. And if we go back to our first solution that we had, you can see that, in the first solution here, you can see that Ehrenfeld and Altstadt are both assigned to vehicle 1, which right now would not be considered as feasible for our custom constraint. So you can already see that our custom constraint changed the solution there and works for this simple rule that we wanted to incorporate. So that's how you can add custom constraints to your model. It's also possible to create custom value functions, just depending on the scenario and the rules that you're looking at.